People often consume the whole fruit of oranges in marmalade and juice, where the skin and fruit are all processed together. This time we succeeded in filming the inner workings of a California processing plant. The oranges are first brushed and sterilized. A fungicide is then sprayed on. While oranges travel along a long line, a wide variety of fungicides are applied. For instance, orthophenylphenol is used to prevent the white fungus, and imazalil and thiabendazole against the green fungus. After hot air is blown over the fruit, a mixture of wax and fungicide is applied to them. After coating with layers of pesticides, oranges with defects are sorted out for juice and preserves, as we saw with apples. Hundreds of times more residues were detected on the skin than inside the fruit. Juice is made from unpeeled fruits, and so it naturally contains a great amount of residues. California cherries are processed differently depending on whether they are for domestic use or for export to Japan. Cherries for export to Japan are treated for preservation from decay and insects. This is a packing house for domestic consumption. Here cherries are sprayed 7 times, the last 2 times with pesticides. First, a fungicide is applied. This plastic strip is all the workers are given for protection from the spray. Cherries that do not meet the standard are sorted out for jams and other processed foods. Right before packing, another fungicide is applied. Cherries are always eaten unpeeled, so the toxic residues must have serious health effects. In this facility for export to Japan, methyl bromide is used to kill insects. However, the use of fungicides after harvest of cherries is banned in Japan. Nevertheless, a pesticide is further applied right before packing here in California. We obtained evidence that cherries are dropped in a fungicide called Iprodione. The producing companies have claimed that no post-harvest pesticide is applied to the cherries exported to Japan. But chemical analyses in Japan always detect much higher levels of residue in American cherries than Japanese ones. The American application instructions state that you should soak cherries in pesticide but not rinse before packaging. We were curious as to how long these American cherries would last. So we kept them at room temperature in July and August. Even after 7 weeks, no fungus has grown at all. Are these cherries really edible? Staples like potatoes and grain require a secure supply throughout the year. If even a little pesticide remains in these foods, then we would be consuming a lot of the toxin year after year. Post-harvest pesticides are not the only problem. Usually the fields before harvest are lovely and green. But the pre-harvest potato fields that we saw were miserably desolated. No leaf or even stem was alive. This is true for all Western countries. The cause of such thorough devastation is herbicides which are sprayed just to make harvesting easier. This kind of chemical is called a harvest aid pesticide. Herbicides completely destroy the natural environment. Moreover, since such chemicals are applied right before harvest, huge amounts of residue stay on potatoes till we eat them. In an American potato field, farmers showed us how pesticides are used prior to harvesting. The chemical sprayed here is Vapam. Because it's a suspected carcinogen, In Japan, its manufacturer has withdrawn its registration. Vapam blocks budding and decay in potatoes. It also works as a weed control agent. Europe is famous for its potatoes, which are widely consumed as a staple food. We made field surveys on the safety of potatoes in England, Switzerland and Germany. This farmer is sprinkling powder with his bare hands. This powder is a germination inhibitor. This yellow bag contains a herbicide CIPC, which causes skin cancer in mice. Yet such a strong toxin is being carelessly handled by farmers. We found this germination inhibitor is widely used in storage as well as in the fields. We cannot overlook the fact that post-harvest pesticide is toxic enough to inhibit germination. In an underground warehouse, stored potatoes are coated with brown powder, which is the pesticide. CIPC is provided in various forms, as powder, liquid or gas. Professionals fumigate potatoes repeatedly whenever they start sprouting. The residue of this CIPC has been detected in Japan from imported frozen potatoes, potato chips and fried potatoes served at fast food outlets. Australia is one of the largest agricultural exporters. Insecticides are used there to stock wheat over long time periods. Right after harvest, wheat is transferred to storage through yellow pipes. An organophosphate pesticide, phenitrophthione, is kept in a blue container attached to the pipe.
Sprinkle what?
Yep.
Enough?
Yep.
Good day?
Yep.
When the machine starts up, pesticide is mixed with the wheat. Consequently, phenitrophthione resides in the wheat and in any products made from the wheat till we eat them. In the United States, another pesticide, chlorpyrifos, has been used for the same purpose. What effects could these pesticides have on the human body? Let's listen to Professor Mikio Miyata of Kitasato University, who is the worldwide expert on this issue. Cedar pollen was applied to the eyes of mice suffering from hay fever, and slight conjunctivitis occurred, as shown here by the light blue color. Then we fed them a very little organophosphate pesticide. We confirmed that the pesticide drastically enhances the allergic conjunctivitis, as indicated by the dark blue color. The dose given was the same as people eat in a single meal with a pesticide contamination of 0.01 parts per million. We bought samples of bread in several countries. Analysis showed that about 30% of them were contaminated with organophosphate pesticides at a level of 0.01 parts per million.